Kinematics. Equation of motion is given by v is equal to u plus a into t, s is equal to ut plus half at square, v square is equal to u square plus 2s. Application of equation of motion. The equation is v square is equal to u square plus 2s. For v is equal to 0, u square plus 2s is equal to 0. Now, this equation can be written as minus 2s is equal to u square. Negative sign indicate that the acceleration is negative, means it is a deceleration, and s is proportional to u square. This equation can be written as s2 upon s1 is equal to u2 upon u1 whole square. If u2 is equal to n times of u1, that is, if initial speed in the second case increase by n times, then a stopping distance of a body increase by n square times. This equation can be used to determine the stopping distance of a car, bullet, bike, or any moving body, in which a constant deceleration is applied for the motion. Example: a car moving at the speed 20 km per hour applied a brake and stopped by traveling a distance 10 meters. If the same car moving the speed of 60 km per hour applied the same brake, find its new stopping distance. This question is based directly on the above equation which we discussed earlier. If u2 is equal to n times of u1, then s2 is equal to n square into s1. In this question, u1 is equal to 20 km per hour, s1 10 meter, a1 is equal to minus a, negative sign means it is a deceleration. Again, u2 is equal to 60 km per hour, s2 is equal to question mark means we have to determine the value of s2, a2 is equal to minus times of a. In this question given that u2 is equal to 3 times of u1, means initial speed is 20, final is 60, the ratio is 3, hence n is equal to 3. Now if a speed is increased n times, then a stopping distance s2 is equal to n square into s1, that is 3 square into 10 is equal to 90 meters. That's your final answer. In such type of questions, we frequently use the above relation that if speed increases n times, then a stopping distance increases n square times. Second application of the same equation, which is v square is equal to u square plus 2s. In this case, we have to determine the additional distance traveled by the body. Let the equation is v square equal to u square plus 2s. In case 1, equation is v1 square equal to un square plus 2s1, and in case 2, v2 square is equal to u2 square plus 2a into s2. If v2 is equal to 0, means final velocity of a body is become 0. Now let the body finally come to rest, means let a condition for the question that the speed of a body decreases n times after traveling some distance s1, and it further come to the rest by traveling some distance s2. We have write the above equation. 2as is equal to v square minus u square, that is 2as1 is equal to v1 square minus u2 square. Again, this equation is written as minus 2as1 is equal to un square minus v1 square. Let this equation be a. And if v2 is equal to 0, as we considered earlier, then minus 2s2 is equal to u2 square. That's equation b. Divide both equation b upon a. We have to write s2 upon s1 is equal to u2 square upon un square minus v1 square. If u1 is equal to n times of v1, that is final speed decreases by n times, then v1 is equal to u2, because the final velocity of the first case is taken as the initial velocity for the second case. The same equation can be written as s2 upon s1 is equal to v1 square upon un square minus v1 square. And if u1 is equal to n times of v1, then the same equation is written as s2 upon s1 is equal to v1 square upon n square v1 square minus v1 square, and it is